First, to add and subtract radicals, you have to simplify the radicand, which is the number under the radical sign. So, to simplify, we break the radicand down into two perfect square numbers, or into one perfect square number that can be multiplied by another, as I'm doing here. The radical sign keeps, and then you simplify the perfect square and keep the non-perfect square. And that's how you simplify the problem. Then, to add and subtract, you put the addition sign back down and add these two numbers outside. 5, 5, that's your answer.
To subtract radicals, you need to do the same steps as adding radicals, but you just subtract them at the ending number. What I'm doing now is breaking it up like we did in the last problem to radical 9 times radical 10. And then you take the perfect square and leave the other radical. Now we're going to do that. We're going to do the same thing to this side. Now we have 3 times radical 10 minus 2 times radical 10. So what we do from here is we subtract the numbers outside of the radical. Three minus 2 is 1, so you could leave it as 1 radical 10, but instead you could just simplify to radical 10. And there's your answer.
To multiply radicals, we can do it one of two ways. First, we can multiply as it is now, or we can simplify first, because you don't need to have the same radicand when you multiply. So, to break it down first, these we can break down to 5 and 4. Then, we simplify that down to 2, 5, 2, 5, and then multiply still. The multiply sign carries down. You multiply these numbers, the radicand and the numbers outside the radical, to get 4 and 5, which simplifies down to 4 times 5, which equals 20. And the second way we can do it is to multiply the numbers as they are now. This breaks down and this goes to 100, 400, which goes into 104. These are both perfect square numbers, so 10, 2 equals 20, same answers we had before. To start the process of dividing radicals, first you have to rationalize the denominator. That means we have to multiply by the denominator to get a perfect square. So, that, and then we multiply through. So, we get radical 18 over radical 9. Now we made a perfect square. Obviously that simplifies down to 3. This, we know from earlier how to simplify radicals. We can simplify this down into 3 and 2. Now, after this step, we're still not done. We have to break this down, and the denominator goes into the number outside the radical one time. So our final answer is radical 2 over 1, or just radical 2. As part of going deeper on radicals, we will be showing how to divide radical binomial expressions. First, we have to multiply the denominator to rationalize it by a conjugate. So we multiply by the denominator, obviously, which would be 5, and then the conjugate would be flipping this sign. So 5 plus radical 2, 5 plus radical 2. Next step is to do FOIL, like we normally do on binomial expressions. So we get 3 radical 10 plus 3 radical 4 over FOIL again. We do radical 25, and then plus radical 10, and then minus radical 10, and then minus radical 4. So simplify all that out. We get 3 radical 10 plus 3 times 2, because 4 is a perfect square, over 5. The 10s cancel out because of the signs, minus 2. Then, one more step, 3 radical 10 plus 6. And then we do, that's 3. So, since the 3 can distribute into the 6 and into the 3, we'll distribute that through, which gives us 2 plus radical 10. And since that's over 1, we don't need to write it. That's our final answer.